Hi, welcome to Sachin Study Tech. Today topic is memory view in Python. So what is meant by memory view? So you can take one example, then you can understand what is the use of memory view. So what is the difference between slicing and memory view? So whenever you can use the memory view, here it is a zero copy access. What is meant by zero copy access? For example, whenever you can take the slicing, so you can take the one extra copy, so you can provide the slicing in that area. But here whenever you can use the memory view, so it is a zero copy, so it cannot take any extra copy, so that is the zero copy. So it is a built-in Python type that allows you to access the memory of another object. Okay, what are the key features of the memory view? So to provides a view into the memory of bytes, byte array and other buffer supporting object, and to avoid the copying data, so it can improve the performance. It supports the slicing and indexing, even cached memory view also it can support. So it is immutable if the source is immutable type. That means what is meant by, for example, I am consider bytes, it is a immutable, right? So whenever you can use the for example, here I am taking one example, then you can understand that. For example, here Python, this Python is converted into bytes type. So for example, here S. So in this case I am taking memory view of S. So in this case, here if you can print MV of for example MV of 0, just you can print MV of 0. What is the value here? What is the value of P? That value it can print. Like for example, it can print 80. Now if you cannot try to modify that MV of 0, you can try to modify that value here, for example 100, it cannot possible, because here the memory view, what type here, it is a byte type. Bytes is a immutable type, so that's why the memory view is also immutable type, you cannot change it. For example, here it is mutable type, that means byte array, whenever you can take that byte array here, so in that case you can use the memory view, so it can support, it can change that value. So that's why here mutable if the source is mutable. Now you can see the one example. Here it is Python, so that is bytes type and also converted into byte array type. Now memory view of data, here memory view of data, print MV of 0. What is the MV of 0? So what is the value of P? So ASCII of P is 80, the value is 80. Now here MV of 1, that means small y value is changed to I, character I. Like that, here you can print data byte array is Python, instead of small y, here you can see the I. But in this case, what is the difference between slicing and memory view? Okay, now you can see the one example program, then you can understand that. So what are the use cases of memory view? Large data set manipulation without memory overhead, that means it cannot take any extra copy. Okay, then interfacing with low level of APIs, that is NumPy, arrays, image library or struct modules, you can use the memory view. And also binary IO, network programming and real-time streaming or buffering, you can use the memory view. Now you can see the one example program, then you can understand what is the. So here I am taking S equal to, here it is Python. Okay, now what is the type of S here? Print type of S. What is the type of S? Already which is a string type, right? So here you can see it is a string type. Now here this is converted into B, that means that string is converted into bytes type, already. So now it is a bytes type. Now here I am consider memory view. Here I am using, for example, one variable MV equal to memory view of S. Now what is the type of MV here? Now what is the type of MV? Print type of MV, print type of MV. Now what is the type here? You can see, so which is the type is memory view type. Okay, memory view type. Now what is the difference between slicing and memory view? Now we can see the like I am using here, I am slicing. That means for example, if you want to print of s of, I am taking print of s of 1 colon, for example 4, 1 colon 4, right? Okay, just if you want to see that it is a YTH, just you can print YTH. You know what is meant by YTH? Here it is P index is 0, Y index is 1, 1, 2, 3. Okay, cannot include 4. That's why YTH it can print. YTH. Okay. Now, what is the idea of this? What is the idea of this index? Now we can see here it can take any extra copy, or you can display the same index. Now you can see that print ID of one colon 4, right? You can see that print ID of S. What is the ID of S? Now you can see, is there any same ID or different ID? You can see here. Now you can see here ID of S is, this is the ID of S. Okay, some S address. Now we can see the slicing here, S1 colon 4, here you can print the ID of that. So it is a different ID. That means you can take the one extra copy for that. Now I am taking here, it is print mv.obj. Here it can take any extra copy or not. If you can see that, here you can see ID of mv.obj. Just you can print the Python here. Just if you can print that, what is the ID of that ID? Just if you can print the same address or not. Now you can see here ID of S is 2729391438 right? Here MV of ID of memory view, it is also same. You can see here also same. You can see that the same ID. What are the ID is there in S? The same ID is there. That's why it cannot take any extra copy. So that is the memory view advantage. But in slicing, it can take the another address. That means it can take another copy. So that is the difference. Okay, now here also can use, for example, here also can use array. Array also it can support, memory view also can use in that. So I am taking a array dot array. So it can expect two arguments. One is the type ID. So now I can explain what is meant by type ID, all these things. Type data here. Another one is I am taking some 10, 20, 30, like for example 28, like that I am consider. Now MV equal to memory view of A. I am consider here the memory view of A. Then you can print that print of MV of 1 you can print. So what is the print MV of 1? That is the value is 20, right? Here you can see that value is 20. Okay, now here in this case And also here in this case also can support the casting, also it can support. Now without first you can see the what is meant by each what is meant by each. You can see that difference, like to list. Here you can print that values. What is the value? 10, 20, 30, 28, right? You can print the same value here. What is meant by H? H means it is a signed sort. H means signed sort. Capital H means unsigned sort, right? For example, you can take the small b, that means signed char. Capital B means unsigned char. And also you can take the I, okay, that is signed I, small I. Capital I, unsigned I. Like that you can take that here. That is the meaning. So now you can see that I am taking here also I am using the casting. Now mv dot cast of, so I am taking here it is b. You can see what is the difference. mvv dot to list. So before you can see here, you can see that print mv dot to list. Now you can see this mv dot to list, it can print 10, 20, 30, 28, but in this case mv dot cast b. So what is meant by b? So it is a signed char. That means here the signed char. Here what is meant by h? H is a short, signed short, right? Here it is signed short is 2 bytes. It can consider the 2 bytes, but here you can represent 10, 1 byte is enough. Okay, cannot take the 2 bytes. That's why here why it can print 10 0, 20 0, 30 0, 28 0. Now you can see the here you can see now I am consider here it is a 10, 20, 30, for example 28. In this case it can require the two here small h means here the signed short, right? It is a 2 bytes. So the 2 bytes is represented here. 10 is here 8 zeros and 1010, right? Here this is the first byte, this is the second byte. So here the least significant byte is printed first. That's why it can print the 10. And what is the value of second byte? Here it is a 0. That's why you can print 10 0. But here it is a 2 bytes. But 10 is 1 byte is enough. That's why you can see the difference here. So that is the difference you can see. Just you can see here I am consider the b, that means 1 byte. So that's why here also it can print 10, 20, 30, 28 like that. For example, I am taking here it is h, that means short, signed short. It requires the 2 bytes. So here every 10 is 2 bytes, 20 is 2 bytes. That's why you can take like that. Okay, so that is the difference. Now I am consider here it is, for example, I am consider here it is 1000. Is it 1 byte is enough for 2? You can see that difference. Now we can see what is the value here. If you want to print that, if you want to see that, here it is I am taking here, it raise an error. What is that error? You can see signed char. Okay, so small b means signed char is greater than maximum. Okay, so that is the error. That's why you can see here it is must be put in, it requires if you can represent 1000, it can requires at least 2 bytes. That's why that is the error. That's why we can take small h. Here also, okay, it cannot represent 1000 in 1 byte. That's why it is the error. For example, I am consider capital B. That means it is a here unsigned character. So it is also 2 bytes. So in this case, there is no problem. You can see what is the output here, 232 3. So what is the meaning of that? What is meant by 232 3, 208 7? Right? If you can see that, print, okay, format, for example, here it is a 1000. The 1000 is represented, for example, in a 16-bit code, that is 0B16 here. So what is the value of 1000, value of binary value of the 1000? Now we can see that 1000 value of 016B, right? Here you can represent it. Now you can see here it is 1000 means you can see that here this is the 4, another 4 is there. So what is the value of this one? This value is 232. So the first 8 bits, the value is 232. So second, this byte, so 0000011, that means it is a 3. So that's why it is a 3, right? It can print like that. For example, you can see the 208 comma 7, why it is 208. For example, I am considering it is a 2000. Now that 2000 is converted into in 16-bit format. Here also you can see that here it is 4-bit, and here also I am considering here also 4-bit. Now we can see what is the value of this one, 111, that is 7. So what is the value of this one? So that is 208. That's why here it can print like that. Okay, but it requires the 2 bytes, at least 2 bytes. Okay, so that is the problem. For example, if we can try to change here, it is a small b, it is a 1 byte. So that is signed char. So it is an error. Signed char is greater than the maximum. So that is the problem here. Okay, for example, you can see that here it is also capital B, that is unsigned character. So here you can see unsigned byte integer is greater than the maximum. Okay, that's why you can use that. Here it is H, signed sort. Okay, that is the value. So this is the difference between, and also if you can see that one more difference here. For example, here in this case I am trying to change that value. In this case I am trying to change that value. You know, memory view, in this case it is a bytes. So if you can change MV of for example MV of 1 equal to 105, right? I am changing that like that. Here you can print of S. If you can print of S, what is the value of S? You can see that cannot modify, type error, cannot modify read only memory, MV of 1, because here it is a bytes. So bytes is a immutable types. So that's why here the memory view also immutable type. So that is the error. Now I am converted into byte array. Now we can see that byte array. So now bytes is converted into byte array. It is no problem. Here you can see what is the output here. You can see the output is Python, Python, yi. So what is the MV of 1? What is the MV of 1? That is small y. So what is the value of small y? Now we can see that just if you want to print ORD of small y, right? If you can print that value, so you can print the integer value corresponding this character. What is the value here? Here it is 121. okay, small y. But here I am printing, here it is I. So what is the I? So character I. Now we can see that, you can see that character I means it is 105, right? For example, you can see what is the capital P, capital P. So here it is 80. So if you can see that, for example, if you want to print that MV of 0, if you want to print that MV of 0, here also in this case you can see it is 80 because capital P value is 80. That's why. For example, if you want to know that here I am taking 105, okay, then if you want to print that character of that, character of 105. So what is the character of 105? That is small y. That's why here MV of 1 is 105. It can print that I value. For example, here you can print MV of 1, that is instead of small y, here you can take the small I, right? That is 105, right? Okay, if you can print that, now we can print S. Here it can change that, here instead of y it can see the I, small I. So here this is the 0 copy, it cannot take any extra copy of that MV, so it can change. So byte array is a immutable type. No, here the byte array is a mutable type, that's we can change that value. So that's why here the MemoryView also mutable type. Okay, so that is the example program. Thank you for watching this video.